this is our new drone system. So we've got a wall 10 high, and currently we've got some materials flowing in. Now, if we look up above, I've changed the orientation greatly because as I was testing things for throughput, I noticed that it took about 5 to 6 drone ports for the really far away locations. So I decided to standardize so that it will be easier to work with. So right now we've got 6 drone ports per material at the most, and then they're color coded, and we've hidden the ports so that the distribution and everything is occurring in a very uniform fashion. We're feeding in rocket fuel, and then we are receiving the goods out the back, and then it's coming down below. So if I actually just hop down below, you'll see that we are just taking these items and we're merging them together. And then we've got staggered containers here. These are just temporary power cables, but staggered containers here that are flowing through. And then you can see the lanes down below. So that's how we're receiving and then transferring our goods up onto the big wall right here. Now, there's a couple of lanes, namely the uranium, which is coming in at 600 per minute, and then the deuterium ingots, which are coming in at 400 per minute. So they will look like they're not consistent, but it's just that these belts are rated at 1200 per minute. So the aluminum ingots, the sulfur, the silica are all going to be continuous, but the other two are going to have gaps in them. The nice thing I like about the system is that if we do need to add more to the belts, all we've got to do is designate a few more of the drone ports, and I have a good feeling that a full 6 drone ports are going to be able to bring in, 1200 per minute, no problem. So that means we can assign 2 drones per pickup point out there, and we can have multiple pickup points, and it's just a matter of selecting a new location where we're going to be picking up from. So it's relatively easy to retool once we've got the infrastructure laid out. So I'm pretty excited about that. I would have preferred to have it go back farther, but we're kind of at the edge of the map right now. So this is as high as I can go for in the meantime. That having been said, it's not going to stop us from extending out this way if we want to add another 10 on top of this, but we'll get there when we get there. Let's start with 10. So right now I'm just interrupting this flow, and then I'm just breaking off into sinks so that I can measure the appropriate throughput. So that's why with the deuterium ingots, you're seeing that there's this empty lane right now, and then you'll see a whole bunch of deuterium ingots come on through, and there you go. You can see the uranium stopping delivery as well, and it's mostly because they're moving at underneath 1200 per minute, so there's going to be breaks in their delivery. But if it's at a sufficient rate for whatever machine's receiving it, then it should be fine. So I have all of our coffee cups, our nuclear power plants down here, and I've separated them into their different stages. So right now we're going to have 3 overclocked nuclear power plants processing uranium fuel rods. I actually had a bit of a calculation error on my notes, and it turns out I need 8, not 4, but twice as many of the nuclear power plants for the plutonium stage, and then we're going to need 4 fixonium nuclear power plants downrange. So how are we going to feed these things? This has nothing to do with the actual items being fed in, but just the chain of custody for uranium all the way through fixonium. So first, we've got 2 manufacturers up front. We're going to be using the infused uranium cell recipe, and then we're going to process the uranium silica sulfur quick wire into 75 per minute of encased uranium cells. Those 75 per minute are going to feed 2 manufacturers, where we're going to use the encased uranium cells with other objects and components to create uranium fuel rods at 1.5 per minute, and then those are going to flow out, and they're going to come on into these nuclear power plants, which are going to be overclocked at 250% each. Then the uranium waste is going to come out of here. Obviously, we're going to need the water as well. The uranium waste is going to come out here, and then they're going to feed into these blenders out here, and we're going to process that uranium waste into non-fissile uranium. That non-fissile uranium is going to come out at 150 per minute, and then that's going to feed the instant plutonium cell recipe so that we can actually create encased plutonium cells at 40 per minute. And then those encased plutonium cells are going to be used for the plutonium fuel unit recipe, where we're going to be able to create 2 plutonium fuel rods per minute. And those 2 plutonium fuel rods per minute are going to feed these 8 overclocked nuclear power plants. After that, we're going to have some plutonium waste. And then the very last final stages are down here. And we're going to take the plutonium fuel waste to turn it into fixonium. The fixonium is going to come out at 20 per minute. And it's going to crank on into fixonium fuel rods at 10 per minute. And then those fixonium fuel rods are going to power these 4 nuclear power plants. So that's the chain. That's what we have to do. Now, there are other things that we're going to have to do outside of these machines, but this is just the transfer, and we're just following along with all of the radioactive material, right? So I was thinking today we could at least get through the very first stage, so to speak, of the process, and we can create some infused uranium cells. I think that would be pretty cool. I think one thing to note, though, I don't recall if I can sync these out, so I'm going to have to be very cautious about how I do this, lest I just build up a lot of waste that I can't sync out. So far, behind me on our wall, we're bringing in uranium, we're bringing in silica, we're bringing in sulfur, and we're bringing in deuterium ingots, which are not quick wire just yet. So if we've got 400 deuterium ingots, how much quick wire are we going to be able to create, right? So if we go production, we go constructor, and we take a look at quick wire, 100 deuterium ingot is going to create 500. So that's 500 times 4, that's 2,000. That's 2,000 per minute quick wire. At first I was thinking I should create a little quick wire facility out here. I don't remember if we need quick wire downrange. Let's go ahead and just check the machines. I don't quite recall off the top of my head. Well, I guess we can just always make it on demand. I don't see a problem with that. Let's do this on demand. That's going to be kind of cool. I was kind of thinking that we would have all the quick wire made in one place. We'd have all kinds of stuff made in one place. But, you know, maybe we'll just do everything on demand and everything's going to be its own separate thing, right? I guess the question is, do we want a road or anything like that? We could pretend like we have a road. Maybe we'll give ourselves 4 lanes this way. And what we can do is just designate all of these in asphalt so that we know we do not want to build in this area. We're just going to try that. So there we go. That's going to be our sort of no build zone. And then we'll go ahead and extend that out farther this way. And then we can start the buildings over here. So now we're going to have 2 manufacturers. And I guess we'll just make our manufacturers here, at least temporarily, so that we can see how much. I don't feel like going over there. Infused uranium cell. So we need uranium, silica, sulfur, quick wire. But we're going to need it in sufficient quantities. We need to come in at 187.5%. So that's going to be 281-ish quick wire per minute. So in order to make that, we're going to need, well, actually, how many constructors, right? It's 60 each coming out. So that's 180. Then it's 6, 4, 240. 6, 5, 300. So 5 should be sufficient. 60 times 5 is 300. 60 times 4 is 240. We need to be right in between, right? So let's just go ahead and make them as quick wire. And then at that point, I guess we'll just bleed off deuterium ingots, no problem. Feed them in here and then bleed off the other lanes, and we've already got what we need. That's pretty cool. So how do we want to do that? I suppose we'll have a logistics floor. We can have a logistics floor. And then we'll extend this out a little bit so we have a little space. I'm trying to think, do we want the manufacturers after or do we want them on top? I kind of want to go inline. So, but with the manufacturer, I usually have a little more space to work with in the logistics floor. So let's just grab, maybe as a compromise, I'll at least put one more basic wall of height. And we'll come up like this. Here we go. And this is going to be our actual manufacturing floor. And we'll pretend that the Caterium is coming in through there, right? If that's the case, then we're going to have our constructors. We're just going to bring this around. I'd like to have a little space when we get up to this floor. And we'll place this right here. 2, 3, and 5. Although, with the amount of space that we have, what if we build it and then it flows down? I'm trying to think, like, do we split to the left and the right and then we join the output together? Or it would be a lot easier, since we're not making a lot of stuff, if it's actually longer rather than wider. So I'm just going to go ahead and extend this a little bit farther. And the reason why I want to do that is so that it's not difficult for me to actually join all of the results together. So with that in mind, I think I'm actually going to place the conveyor wall out here. I'm going to turn these around like that, because I want to feed a manufacturer too. In this case, 2 manufacturers at 187.5% will set the recipe. So they're all going to be at quick wire, like so. And then I'm going to go in and color them up. So we'll go Caterium. And then to feed them, just have these right here. And then we'll feed like this. Okay, so we'll actually just take the bottoms, we'll bring them down. Looks like we gotta face this way, because if we're coming in, we need to feed it directly, and there we go. So we're gonna manifold that through with Caterium ingots. And if you're always like I find that if I'm a half click off, meaning these lifts aren't going to be able to receive it directly, they're just sort of like 1/2 click over, I can actually do something like this and it will allow everything to line up. So we'll kind of do the same, just all the way across. So we're going to have 5 of these. And we're going to be removing, what is that, like 12 times 5? We're going to be removing about 60 out of the 400 per minute of ingots. Actually, a little bit less. So let me go and bring this over. Let that flow on down. We'll go ahead and connect them all. And that's going to be the feed. Like that. There it is. So those are all going to feed. And I'm just going to go ahead and get 1 power pole Mark III, and we're just going to connect them all so that they all have power. And I've actually started to use the single poles more often, because then when I actually want to do the wiring where it's pretty, I just remove 1 pole instead of having to go to each one and individually remove them. And we can just kind of place that there for now. So now they've all got power in the meantime, and we'll be able to feed in the Caterium ingots. So it's just a matter of bringing this on over. And we need to peel off of this 3rd from the bottom lane. So I'm going to go ahead and grab a lift. 1, 2. And then we'll hold control. And lock in right there. And when the Caterium ingots go on by, they'll shoot through and start feeding the machines. So there it is. Now the question is, we are going to have a manufacturer. Do we want it on the same floor? I mean, I guess that makes sense. It wouldn't be bad to have. If they're all coming this way, then they can kind of feed back down. And then we can maybe have a manufacturer facing out this way. And then output would flow out and move towards this direction, I say. So, gosh, that didn't make much sense. Let's. What I can do is just get the manufacturer. We could put it on top. It is always possible. There we go. They're all flowing in now. They're peeling off. Kind of interesting that some of them fly right on by. Well, I guess with this, we would probably need to prioritize, like, actually, now that I think about it, instead of using a regular splitter, we may have to use a smart splitter. And then we're going to prioritize that the ingots go to this first. Yeah. So we're going to say Caterium ingot to the right. And then we're going to say overflow downrange. And that's going to make sure that this thing is fed to the maximum. And then all the overflow is going to continue down. I think that's going to be a better situation. So once those are all singing, they're creating quick wire. That quick wire is coming on out. They'll be able to join together. Maybe we come back down below. And then we'll merge them all. I'm like making this up on the fly. I have no idea what this is going to look like at all. At all. All right. Ooh, this is not even feeding. It's not feeding it at all. Oh my gosh. Wow, that's something. Here we go. I was wondering about that. There we go. It's a good thing we check them. There it is. Now she's singing. Awesome. All right, so now it's actually prioritizing the right side, and this is not going to get starved thanks to the smart splitter. And the fact that stuff's flowing through tells me that these are all saturated, so that's great. So now we'll be able to merge these together. I'm going to go ahead and face away from the machines. And I don't know where I want the output to go just yet, so I'm going to hold off on inserting the mergers. This is a pretty narrow set right here of constructors. We do have a manufacturer. I think the manufacturer is going to take up at least 3 wide. Like if I put 2 next to each other, we're probably going to want to have at least 6 wide. Currently this is 5 wide. So if I did something like that, then I'd be able to fit 2 manufacturers side by side. If I have the manufacturers facing this way, I'd be able to fit 2 side by side. We could try that. Then I'd probably want to have a little bit of space in between these 2 right here. So I'm going to go ahead and do... Let's extend it a little bit more. And we'll go manufacturer out like this. I'm going to put hold. And we have an even amount of spacing here. And they're aligned. So there it is. So we're going to have it like that. And then I'm going to be able to cut off the end that we're not using. And if this is all in the same room, then we're going to have a lot of the materials flowing in through here, right? So let's see. We can stagger them. I probably want to feed from the same direction, or I suppose I could feed from the opposite. So what I can do is head on over, merge away from the resource wall. So we're going to merge all the quick wire down this way. And then it can come out here and then loop around. So we'll have the closest one right next door because they're moving along the ceiling. This is going to be the quick wire entry. So we'll go with Caterium. And then we'll face where the Caterium is coming from. And then switch to a splitter so that we can distribute that quick wire. Are these in line? They're not quite in line, so I'm just going to have it come out this way and come in this way. Like that. There we go. So the quick wire is going to feed that way. There it is. And we have enough space that we can take the manufacturer feeds and we can pick up goods from down below. So that means we're going to want the other 3 goods to probably be in here, although we can also receive from underneath the manufacturer. That isn't a problem. So what we can do is just, let's go ahead and just figure out where we need to place these things. I can probably actually, I kind of like using the glass to figure that out. So I can go to architecture, I can go glass frame foundation, just bring that over so that I can actually see. So when I'm placing the floor holes, that helps me to plan the location a little bit better. So for this, I can actually put a floor hole right here. Right there. and then pass in goods from here like that. There it is. And then we'll just drop this down on the bottom, at least momentarily, and then we're going to go ahead and set up the port walls. So I suppose, where do we want it to be more dense? We could have single ports per wall like that. I guess that's probably the easiest thing to do. When I have them so close together, then it gets a little difficult sometimes to move left or right with the lanes because they're so close. So if I have something out like this and I have a port right next to it, it might be difficult for me to move right or left if I don't keep that in mind. So let's see. We're going to pass something in from here. So let's just line up splitters from there, that position, like so. Yep. And then we'll reconnect it so that we're receiving. There it is. So that's going to be one material. No idea what it is yet. And then we're going to want silica as well. So we can probably fit in another one right here. So if I take this and replace it with glass so that we can see, then I'm probably going to want another one bumped over, let's say here. Then we'll flow out this way. And then down below, we'll be able to receive from the right side instead. Now that I think about it, having an input right here wouldn't make much sense because we're already receiving from right and left. We'll probably need to raise something off the ground and then fit it in here somehow, right? Like drop another one down, but then feed from, let's say, here, but raised instead. Something like that, except the input is up here. Or actually, you know, just to make it more uniform, we can actually put the input and then put it on a lift and do something like that. That would work out pretty nicely, I think. So let's just grab, we'll just grab a splitter to the lifts like so. And is this aligned? This one might, yeah, that one's aligned. So I need to bring this a little closer to the left then. Something like that, perhaps. And then we just need to make sure these are attached. Like that. Although I think this one's off from the other. They're different because the distances are different. So actually, I can actually move this one back to where I had it. I guess it was right the first time. Just so they're uniform. There we go. All right. So that's another set of ingredients, and that's feeding in this way. And then we can actually maybe tighten it up again. And let's see if that occludes with anything. It shouldn't. Looks pretty good, actually. And we'll just receive from this side, which is perfect because we already have a lift at that height. So that works out really nicely. Okay, so we're almost done with that first set. Obviously, I'm curious if the quick wire is going to clip there, but we'll see. We can always move that belt around. It doesn't have to be exactly there. It does look like we're going to clip. So what we can do is either play with the height and bring that a couple of clicks down. I might do that, actually. That's probably the easiest solution. So let's try this. I'm actually going to bump this 2 clicks down. And we're going to have to do the same with this receiving port. 1 and 2. And then we're going to come in from this side. And I think it's going to sit right in the right place. And then obviously we're going to have to bring these down a couple of clicks as well. 4 inputs is a little challenging at times, but I'm glad we have this space. Most likely here. Yep, perfect. And then we'll just have the merge come out this way. And then we'll just merge down the lane. So 5 constructors worth of quick wire. There it is. Okay, great. So that quick wire is now being fed appropriately, and all we got to do is hook up the other sources. So one of them silica, one is uranium, and one is sulfur. So let's see, what do we have? The silica, I suppose we can start with. So let's go ahead and just bring this closer to the edge of the asphalt. And then we'll just get, let's say, something along these lines. And then we'll just run her right on down like that. There it is. So now we're starting to get more silica. So I'm actually going to go ahead and use a smart splitter again. And we're going to prioritize the right output. Like so. And then overflow down the lane. And then I'd actually just like to color up as we go. So I'm going to go ahead and say this is silica with the lane so that it's easier to see once we're down below. It's not too bad. And then I'll go ahead and color the top appropriately. And then I can actually already replace the glass. I'm probably going to go with our usual like coated concrete, but in the meantime we'll just keep it as regular concrete for ease of building. And let's just follow the lane for Caterium. So we just want to make sure that we're all Cateriumed up. These are the outputs right here that we are merging together, and then it's going to feed the 2 manufacturers, which I don't recall if I already put them at 187.5%. It doesn't look like I've even selected... I haven't even selected the recipe yet, so no, I have not. So we'll go 187.5, and then I'll go ahead and copy that over. And we'll just make it, let's say, an unpainted look. And we're going to make encased uranium cells. Actually, since they're uranium, I'm going to go with the... We'll go with this motif. That seems yellowish greenish, right? Excellent. So 14280, we're producing 300 per minute a quick wire, so that's sufficient. We have sulfur wise, we're pulling in 1200 per minute. Silica, we're pulling in 1200 per minute. Uranium, we're pulling in 600 per minute. So we definitely have enough. We definitely have enough. Let's make the next one the sulfur. Let's do sulfur. So we'll just go ahead and bring this straight up to the edge of the asphalt. And then we'll raise this up to the sulfur level. 1, 2, 1, 2, like that. So I'd like to use the smart splitter. I mean, I know what I can do. I can just place it at the bottom until I get up here. And we're going to cut this right off. Smart splitter, and I'm just going to receive from that end, and then we'll cut out the ones below, and then we can just manually hook it up. So it is going to go from that source of sulfur straight on in and come out the other side. So we're going to force it to be connected. So I'm going to go ahead and just mark up the colors, and now we're good. And then we're going to bring this up and snap in. There it is. So that's going to be sulfur. We just need to make sure the right is designated for sulfur. And then we're going to overflow down the lane. And that should start to come out. There it is. Perfect. I was a little worried there inside, but it turned out well. And then we're just going to color everything up right there. Perfect. And then the last one's going to be the uranium. So we're about to irradiate this place. If it wasn't irradiated before. So let's just pre-color. This is the uranium. So what we can do is just run this along the ceiling This is, I found the easiest way to do it. And then we'll just get a splitter and hold control and then snap that off right there. So we'll go in and just mark it up in color. And we don't really need the splitter here because it's the end of the line. So we'll actually just come in on straight like this. And then we'll mark that up as green. There it is. And that'll just split off into the correct places. So it's just a matter of bringing in all of that uranium. So we'll come up to the very edge right here. And then we'll just bring up a lift. And then snap it. There it is. So I'm actually just going to make sure once again that it's a smart splitter. And we'll select uranium here. And overflow down the lane. There it is. And then just make sure that this is actually connected. And there she goes. Excellent. So green, green, and green. Perfect. So this should be fully fed once we give it power. So let's go in and power up. And these are going to crank in. There it is. High five. Look at that. All right, she's moving. So we're going to crank out 75 per minute of encased uranium cells. The big question is, can we sink out encased uranium cells? Something tells me no. Something tells me it's, you know, it's radioactive, so they're not going to let us do it. So let's just double check first. So I'm going to go over to special, awesome sink. And we're just going to double check, is this actually going to flow in? And we'll just hook that up to any old power. Yeah, looks like they flow out. Perfect, perfect. So that's great. So we're not going to get a buildup. That's excellent. So I am for sure going to just get an awesome sink and start sinking this out so that this can continue to flow. And then we'll see the real throughput on the resource wall out here. So mind you, we're overproducing with the quick wire. Right now we only need, what, 140.625 times 2. That's 281.25. Right now we're getting 240. So we really only need 41.25. So we can actually change it so we're only pulling off enough. This is going to be 41.25. That's going to have the exact output so that we're not backing up or anything like that. So that should give us exactly the right amount of quick wire as an output. So we're taking 80.25 deuterium ingot per minute. So let's just mark that up because I'd like to keep track of how much we're peeling off of the full 400. And we can have this be 80.25. I believe it was. Let's just double check for a second. 72 plus the 8.25. Yeah. So it's going to be 80.25. And this one's deuterium ingots. Excellent. And then I'll just get these signs and let's go ahead and just place them on top of each. We'll go 93.75 and then we're going to mark this up as uranium. Gosh, I'm so glad that we took the time to automate the iodine infused filters. That just takes the edge off and I don't have to worry about it. We have I have 232 filters in my inventory right now. That makes this a lot nicer to work with. All right, so those are all marked up. So let's go ahead and just, I guess, put on the walls and seal this up. And that is not a bad start. All right, so I'm back. All I've done is I've put a coated concrete floor on the bottom. And let's go ahead and finish the rest of it together, right? So I'm actually going to open this up because I think, you know, this is probably an equal-ish space. Like we left this about half of a foundation on that side. We've got a little tiny walkway right here. We're leaving about half a foundation on this side, so that should be fine. And then we'll be able to clear out all of the remaining walls right here. And we'll be able to, you know, turn it into a building together. I think we'll do the whole process, yeah? So with that in mind, I think we're probably going to just be able to do this one today. But, you know, we can do like one each episode, and I think that should work out pretty nicely. So right now the output for the infused uranium cell, we're just coming on down this way because we only left ourselves 2 basic walls high. We can't fit an entire industrial storage container, but we probably don't need that much for buffering. So I'm just going to go ahead and line that up, place a singleton container down, and that'll start to flow right in, right? So there she is. She's climbing in. She's climbing in. There it is. So that's making its way through. Obviously, I probably want to be sinking right now just so that this doesn't build up too much and it can continue to process. So maybe in the meantime, I will have an output. We'll grab one of these port walls down here like this. And I'm just going to have it here so that we can kind of extricate it from the building. We need to have an output anyway. So instead of it all just building up here, usually overflow I'd probably want to have on this side. But in this case, I just want to make sure this continues to flow. Like period. That it just continues to flow. Rather than build up a whole container of radioactive goods. I'd rather that this just gets sunk out. So I'm actually going to pretend like this is the output to the next set of machines. And then I'm going to just sink it in the meantime. So I'm actually going to mark it up as red so that I know that's what I'm doing. And then I will just get a sink and just cram it on out here. It's going to be the output. So get that, and then hook that up. Perfect. There it is. So that's just going to continue to sink out all the radioactive goods right there. And it's going to be sinking out faster than we can fill that box. So it's going to keep that box empty, actually. So this thing, all of that's going to sink out much faster. I guess the question is, what is the regular output rate? Right now we're making 75 per minute. So I'm just going to go ahead and pre-mark it because this is going to be the output later. So we'll go, it's not going to be a sinking point. It's going to be the output. And I'm just going to get a display sign. And this is going to be 75 per minute. And then I'll just choose this layout right here for the picture. I realized I didn't put per minute on these. So I'm going to adjust these just so that they follow suit. And I kind of want to have this where it's pretty easy to walk in and handle maintenance. So if I were to open this up, where's the best place to put a door? Probably here, I imagine. So we can actually put a door wall right here. So we'll say center door. And it's just going to let us in and do maintenance like that. There we go. So if we're cruising along and we're like, oh, okay, this is going to be the infused uranium cell building, then I'm going to want to, you know, come on in and just check this out. So I guess I'm going to take the same exact sign right here. Or better yet, let's get a billboard. So we'll go organization. We'll say small billboard. Yeah, that's a good size, I think. That at least looks a little bit better. So, you know, we know what it is that we're making. And this is the output. Infused uranium cells. They're fully drained out. They're coming out at 75 per minute. That's looking really nice. All right. So inside, I like this. This is cool. The box is really just here so that, you know, if we ever, for some reason, have some kind of stoppage. I actually don't think we need the box, but it is there just in case. We'll need to do the wiring. We'll need to do the warnings. We'll need to do the roofs. And I think that's it. So let's go ahead and start with the windows. And we're going to use the same full frame window right here. And we're going to need to come up 3 4-meter walls, I believe, because of the height of the manufacturer. Wow, this is going to be our first building. That's pretty cool. This is the very beginning of it all. Oh my god. I have to admit, I've been really intimidated by this process. I've gone back and forth in my brain so many times and haven't actually arrived at any solutions. So seeing some of this actually come to fruition and work, even if it's just a simple thing, is a real relief to me to see. So I'm very excited about this. So we'll go architecture. We're going to grab I like the 2-meter corner roofs, although I do find it easier to actually put these down first like that, and then we can sort of point at it and it should appear in the right place. There it is. And we'll bring that around. and just nab the corner. Actually, is that going to be high enough? No. No, it's not, actually. So I might have to go for the 4 meter, now that I think about it. Just because of the light. Or we need to go a whole nother 4 meters up. I'd rather avoid that if possible. And the 4 meter does look like it's going to work. I do find them to be a little bit steep for my taste. But let's at least see what it looks like, and then we'll go from there. I'm probably going to change the material so it's actually the fix-it roof material, which I actually kind of enjoy. I don't want to do the whole thing in steel. It starts to look like a shack. I mean, I suppose it is a shack to some extent, yeah. So we'll get flat roofs. And we'll bring this all the way across. I guess material-wise, we'll just save... Well, I actually like tar roof. We can try tar roof along the sides. So steel and tar. And then I like having the natural lighting because I don't like to bother putting in the actual lights on the top. So we're going to have natural lighting in here. So with the door, the maintenance door down below, we can have the entrance, let's say, I guess there's this like empty space right here. So we can actually enter through here. I don't see a problem with that. That could be an easy way up. But something is telling me I don't like how that looks, because it comes out pretty far. I mean, I guess it's not horrible. It's not horrible, but I think what I'm going to do is follow suit with the architectural style that we've kind of set for ourselves. And then we're going to have it collapse down like that. There it is. So at least, you know, you can come in here or you can come out this way and then come inside like that. And we're going to go with a side door wall so it lines up more with actual stairs themselves. We'll steel it up so it matches the rest of it, and that's looking pretty all right. Looking pretty good. Looking pretty good. Okay, so now let's go inside, and what we mainly have left are the warnings and then all of the wiring, right? So let's go ahead and start with the warnings because that's a little bit easier. So we'll kind of just get our lanes here, all the lines. I always have trouble with these down here, so what I end up doing is just opening it up. And if you paint the bottom of it, you actually get the top as well, so that's actually pretty nice. And then I can actually use this and actually get below and paint like this, and that should take care of business. There we go. Awesome. Feels like cheating is what it feels like. And then we're going to come up on the half right there and then switch over to full, and it will already be correctly oriented so the lines line up, and that's looking a lot better. Excellent. Now, curious why this is all backed up. Looks like it's not sloughing out the quick wire fast enough. Out here, we are low on uranium. Ah, we have 300 per minute, so I'm curious why that isn't flowing the way that it should. If I look, it is in fact prioritizing that output, so it should be getting the full input, period. We have 172 items per minute coming in. That's draining out, which means that's now flowing again. Oh, you know what? Are we out of rocket fuel? So I didn't actually create a rocket fuel drone, so that would explain a lot. Apparently our drones are running out of fuel because I haven't set up a fuel drone yet. I just had a big bin with stuff in it. And the main reason why is because at the very edge of the world here, I'm going to be building like this. Darting in and out to make it, but you know, it'll get there. It'll get there. I just want to make sure that everything's all fueled and actually supplied. So it'll be interesting. This is definitely a high priority to get a fuel drone made, right? Definitely having uranium flow issues, thus backing up the quick wire production. So let's get the wiring done. Where's the power going to flow from? Like, how are we going to get power into this thing? I guess the nearest plug is probably towards the nuclear power plants themselves. So we can pretend like the plug is going to come from that side, you know? It's like they're powering themselves, right? So the nuclear... We need this building in order to power nuclear power plants, but then the nuclear power plants are also powering the building. It's a symbiotic relationship. So I'm going to go ahead and grab, let's actually get some pillars going. So I'm just going to open this up so it's a little easier to work here. And I'm going to grab architecture. We'll go painted beams. I'll switch my hotbar so I'm working with the beams. There it is, the electrical hotbar. And the plug here is on the left rear side. For big machines like this, I do not mind just having a painted beam that comes straight up to it. So I guess, well, not necessarily. So this is what I'm talking about. I can actually get the plug, put it right there, it'll connect, and then I'll plug the top like that. And then they'll just be super short and super connected. So I'm going to do 11, no, I'm going to do 10 meters. Like this. Then we'll put a plug sideways. And then I'm going to pop a top right on top. There it is. So that's going to look like that. If we open up down below, we can actually extend the painted beam down just a tad, maybe like 2 meter. And I'm going to do the same for the other one. So we'll open this up and we're going to extend it down 2 meter. So we want it to be identical. And we'll do our connections down below where you can't really see it. So I'm going to go ahead and let's see, we have our power coming from that side. So I'm going to make a double plug. So I'll go 4. And I'm going to put the double plug that way. We'll connect down below so that it's a straight line. And then I'm going to get the... do I need a double plug on this side? You know, it wouldn't hurt. It wouldn't hurt. So I'm going to go ahead and get another double plug. And I'm going to connect from top to bottom like so. And then I'm going to connect this cable to that cable like that. There it is. And it's not clipping. So that works out very nicely. So I can actually close this up. And we can use this plug to route it over to the constructors on this side. So we'll go ahead and just do the regular arch beams. So we'll go beam right here. And I'm going to bring this up to 8 meters. That seems to be my standard. Oops, that's 9. Actually, you know what? Let's take this moment. And I'm going to get the beam. We'll bring it up to 8. We'll bring it across. And then I'll cap the corners. And down below, we can extend this one down 2 meter as well. And then we'll have a single plug. So it'll be like this. And we'll just connect the two together. Like that. There it is. Perfect. And then we'll just cap off the bottom. I'll have a single plug right here. That'll reach down below. We'll go and close that up. And then it's just a matter of putting the single plugs centered with the constructors. Connecting them all together. There it is. And then all we got to do is make sure that we actually have a double plug going through the wall. So that's here. So I'm just going to go in and connect this one, and we're going to run her straight across. I suppose it's kind of in line with this line right here, and we'll move it right to the intersection right there. And let's go ahead and take a look outside and see what that looks like. So the plug is sticking out on the outside going to be the access point for power. Yeah, don't look too bad. Don't look too bad. That's not bad at all. All right, so everything is hooked together. It's just a matter of getting rid of the single pole, right? So we get rid of this one pole. Everything shuts down. It's horrible, my God. And we just power. Just connect all the plugs. This one right next door. This one right next door. Super tight, super clean. And then we just got to plug in outside. Isn't that awesome? So we just step outside, pop the rail, and then we just hook the whole building up from here. Maybe downrange. And we should hear things power up. And there she is. Look at that. All right, excellent. So this whole thing is now wired. It's got the warning signs. It's got a roof. It's got a logistics floor. It's got an access point for maintenance. All we got to do is close this up. And she is complete. That's awesome. So the output is just sinking out right now, but it can go into a bin. So not too shabby. I'm going to have to figure out the whole uranium thing. I think it should be processing, right? This should move. Okay, good. It should move. It should move. Okay, fantastic. So that's not bad. That's not bad. We have our very first infused uranium cells being completed. And after that, it's just one more thing, and then we get uranium fuel rods. I had no idea that it would be so small. Now, obviously, that one was more simple, but the next one's a little more complicated because we're also going to need to create the encased industrial beams, the electromagnetic control rods, and then we're going to take the encased uranium cells from the building we just created. So it's these two that we're going to have to do in parallel and create those either on site or fly them in. And then at that point, combine them, and we're going to get our first uranium fuel rods. Now, when we do manufacture the uranium fuel rods, we're going to need to note that once we power our very first nuclear power plants, we're going to have uranium waste. So we're going to need to do something with that. So these uranium cells can be sunk out, and I believe the uranium fuel rods, I don't know if they can be, so we may just turn it off and stop it there, but have it available once we can verify and produce a little bit of uranium waste and just put it to the side in the meantime. But this is a good start. This is a good start. We've got some type of drone logistics network back there. We've got a resource wall, which is heading down range. We are currently just sinking stuff out to measure throughput. And then we have our very first infused uranium cells. So very, very nice. Well, bunnies, thanks so much for hanging out with me. I think we did quite a lot today. We were able to kind of make our first steps towards nuclear power. And I couldn't be happier with the results so far. So hopefully you enjoyed yourself. If you did, please feel free to like, share, comment down below. It helps us a great deal. I had a total blast. I hope you did as well. And I can't wait to get into the next one with you. Have a wonderful, wonderful night.